All right, I guess I'm live. Got to do the usual routine here. Fix this and that. So I'll do that. Check to make sure the mic's working. I guess I'm live. Got working, so we're all set there. So, yeah, just a quick video to respond to a snarky comment and such. Mostly on the subject of velocity, acceleration, inertia, the condition of your movement. So I just typed out a transcript of one of the answers. This is Michael Corson. He gave to my question about mass and the theory of relativity. His question on relativity was about mass increase. My argument is mass increase is just a logical consequence of velocity increase. And the mass is in the form of energy. So I was attempting to cite an example I've given previously. So I did in very brief form. So I said, well, fuck that shit. Obviously, they become heavier because they have force in them. Force is a real thing. So that's an important sentence. If you're moving, so I was describing this with my hands, kind of doing this space shuttle thing. If you're moving velocity of the space shuttle, I have used this example of a space shuttle, a giant flame coming out of one end. And what's doing the equal but opposite reaction thing? All right, it's capturing giant flame inside itself, collecting giant flames. So the flame, I'm just trying to point out, there's a flame inside the shuttle, essentially. Doesn't necessarily mass. I didn't say that. It doesn't necessarily mass. I didn't say that. It has mass as force. And obviously when it hits something, all that flame is going to show up because it's real. So just making the point that the flame keeps burning, the shuttle keeps moving, and all the energy that you see coming out the tail end is energy that's now in the shuttle. And that when it does crash into something, you'd see all of that energy released. Perfectly rational explanation of how physics works. So, smartest man in the world, ladies and gentlemen. So again, and their explanation is nothing. I guess he knows I'm vegan, and so he gave me word salad to feast on. Ha 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 ha. Fuck you. I mean, it's just such an idiotic. So I'm just going to do it redundantly. I'm going to go over it again just for this asshole and explain how their physics has no explanation for velocity. They just say something moves because it keeps moving. So if this is space, empty space, we don't have gravity affecting it, it'll just keep going. As if there's a magic keep going quality that this pen has when it keeps going. And it's the same exact pen that's sitting still. And it just has keep going quality, some sort of magical quality. So, to the drawing board and such. Bigger now. Yeah, yay, maybe. Uh-oh, slower though. Yeah, so that's a disadvantage. So, bigger but slower. So, all right, so that's something to learn. It's kind of weird though. I didn't notice that it was slower. Maybe it's just because I have the image bigger. Let me try making the picture wider for my purposes. Maybe for my purposes. All right, so should have got this technical difficulty figured out ahead of time. I mean, the paper's crooked. It means the camera somehow crooked. Now, whatever. It's, you know, it's a technical world with technical problems. Yeah, it is a much slower. Well, I could try it in a smaller resolution and see if it regains its regular speed. That's pretty cool. It's a little slower, but yes, much better. Yeah, I can't resize the window, unfortunately, so we'll just see how this works out. It's all a work in progress. It's brilliant enough that I'm able to do this split screen without it completely failing. So can't complain if everything isn't just perfect. So the idea is the space shuttle, it's got its little rocket engines. So it's got 3 or 4 of them, 3 of them, I guess. But the point would be is that this big flame comes out of here. And the idea is the flame, is basically an expansion. So when little atoms are expanding, they expand in all directions. So that's kind of the equal and opposite reaction, is that it's expanding. Something expands. Something goes 2 ways, this way and that way. And when you have a bunch of it, it's going this way and this way. It's going all kinds of ways, but it's expansion. There's a left and a right. There's a action, and the reaction is built in to all these expansions. And all these expansions are essentially energy. And the idea is to try to divert the energy, that is, give it a bias. So what the rocket engine does is it takes this expansion and puts it in this, it forces the expansion to take place in one direction, essentially, by basically just taking advantage of the fact that expansion in this direction or this direction will end up being converted into expansion in this direction. And so, but the idea is this is all waste. This is all stuff going this way. And the equal but opposite reaction has to be stuff going this way. So it's a clear illustration. When you look at it, you're seeing a tremendous amount of energy going this way. You're not seeing any energy going this way. All right, it doesn't have the form of flame, but the same amount of energy is actually being added to the matter of the shuttle. So which each second that this thing burns, there's a second of this giant flame, and it's going inside. And the next second, there's another flame, and it's going inside, and then another flame. And it's all going inside this shuttle. Each second, it just keeps adding more and more flame inside here. And it doesn't lose it somewhere. You don't see it leaking out. You don't see any fire going this way or fire going this way, or any evidence of the fact that it's absorbing all this. All you have is the movement of a lot of mass. So tons of mass are now moving in a velocity. And that's essentially equal to this flame. And until the shuttle gives up the flame, that is, until you force it to stop moving, you won't see any of this energy. But obviously, if I put a brick wall in front of the shuttle, say the shuttle is just sitting on the the runway and it's not doing anything, it's just sitting there looking shuttly on its little wheels. Well, I could put a brick wall there and I can push it into it, but nothing's going to happen because it hasn't collected any flames. It hasn't collected a bunch of force going this way, which has the opposite force going this way. So it hasn't collected anything. It doesn't have it inside of it. So the difference between this pen when it's standing still and this pen when it's moving is something inside the pen. Just like that flame is inside the shuttle. And you'll see that energy if it does hit a wall and it's going really fast. You'll see the sparks and the flame, and you'll see what was trapped inside of it. And that's the increase in its mass with its velocity. You're increasing its force. Its mass is really just a movement of a scale, in a sense. If I put the scale sideways and there's no flame coming out of the shuttle, the scale doesn't register anything. 0 pounds, it says. But if a flame's coming out and the shuttle's absorbing that flame, well, then you'll see pounds. It's 100 pounds, 200 pounds, 300 pounds, 400 pounds. And all of a sudden has mass in a direction. And that's all mass really is mass in a direction, ultimately. And that direction is decided by what forces have acted on it. But it's just a simple illustration that energy is a real thing, and it really is converted into mass, in the sense of when it's not on fire, it's being held as potential energy. It's inside the arrangement of the atoms inside of the space shuttle. The arrangement of the shuttle flying is different than the arrangement of the matter in the shuttle not flying. The atoms are more compressed. They're closer together, let's say. They're creating more pressure between them. It's increasing its voltage in a way you could think of it. Its potential is increased by the absorption of this imbalance in force. A lot of this way shoots out, and a lot of this way stays in. And it'll keep going until some equal force, some other flame, or something that's been pushed by a flame hits it. And that's when it loses its inertial condition. But yes, all these things are, velocities are all push and pulls. So in this case, when the shuttle's taking off, it's fighting gravity. So as it's fighting gravity, it's losing some of its force to overwhelm the force it's cutting through. It's plowing through, it's absorbing. And it's absorbing more force going this way than against the gravity. But if I put it in gravity-less condition and let it go, once it gets far enough away from the Earth, it doesn't need a flame anymore. It'll just keep going based on the flame that's still inside of it, the energy that's still inside of it. And again, that's the difference between the moving object and the one sitting on the ground. So I just thought I'd reinforce that it's a perfectly rational analogy explaining the quality of inertia and why it can be represented as mass. Force, when held inside of something, can be thought of as mass in that direction. Not an unreasonable concept. Only an asshole could find reason to disregard or insult the concept. A complete fucking asshole. All right, me versus the rich. Retracted his comment. So, I guess that's all I need to do this video for. There aren't any other comments relevant to the subject. So, keep it short and sweet. So, till the next time and such. And so forth and whatnot. Pretty much. Still, the resolution still not filling the whole screen, which is a little irritating. But what are you going to do? It's cutting off a little bit at the edges, but YouTube, nothing I can do. So it's a form of pressure. Well, it's pressure held inside the space shuttle, and it obviously has an orientation and a direction. Really not doing the hello thing, I don't think. Yeah, so it's an inertia room. I don't think you people have any further. I don't think there's anything further to say. This is a perfectly good analogy for the function, and I shouldn't have to bang anyone over the head with it. So I won't. So anyway, yeah. So there's no. Yeah, I don't need to do another live room. I already did one today. And people are just idiots. So it's always a waste of my time. But anyway, till next time, such.